Hey there! Here we go into a very cool problem type that is often asked in textbooks everywhere when it comes to power series. A little bit more of a challenging looking problem, but it ends up being less challenging than you might at first think. I've seen it on the BC exam a handful of times, not often, but it comes up enough. All right, let's take a look. You've got show that y equals this is a solution of y double prime minus y equals 0. So how do we do that? Because it looks very intimidating. What you do is actually follow the ingredients of this recipe. What do I mean by that? You're being told find the second derivative, subtract from it the original function, y, this thing, and show that it equals 0. My technique for doing this is just expand out each of the terms for these. So y double prime, find it, and y, and then subtract them and show that it's 0. So how do we do that? Well, y is equal to, and we'll just expand it out, go term by term. If I plug in 1, that's negative 1. This is going to be x to the 0, so that's just negative 1, like that. All over, and if I plug in 1, that's going to be 0 factorial, which is 1. So the whole thing is just negative 1. Then from there, if I plug in 2, you're going to get positive 1. You'll get x squared all over 2 factorial. And you're going to start to see a pattern emerge here. Then if I plug in 3, I'm going to get minus x to the 4th all over 4 factorial. Then plus x to the 6th all over 6 factorial. Now, if you notice this, there is a shortcut to it. So we'll go out to the nth term, negative 1 to the n, x to the 2n minus 2 all over 2n minus 2 factorial. You might notice that this is the exact opposite of cosine of x. So if you notice that, we could do it that way. More on that in a little bit. I like to expand it out. I think that's the way to go. But if you notice that this is cosine, this problem becomes butter. More on that at the end. The derivative of this, we're going after the second derivative, is, well, that goes to 0. We're going to simplify this down because we want to show that these things subtract out. So 2 times x is what you'll get on top over 2 factorial simplifies to just x. Minus 4 times x cubed, the 4 and the first 4 and 4 factorial simplify. So that's going to be x cubed over 3 factorial. Plus, the 6 comes out front. And you get 6x to the 5th over 6 factorial. The 6's cancel. And you're left with x to the 5th over 5 factorial. Plus, you might be noticing something here. And I guess that would be minus there if we're following the pattern. So that'd be minus dot 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 plus. Now the derivative, it's still negative 1 to the n. The 2n minus 2 comes out front and cancels with this first 2n minus 2. And that leaves you with x to the 2n minus 3. All over that same exact power. Now this doesn't look familiar because of the 2n minus 3's, but if you look at the pattern of what's going on here, it's sine. Literally, this is sine of x. Pretty cool. Y double prime is equal to, we'll take the derivative, that's going to become 1. This, well, the 3 comes out front, becoming 3x squared. The minus stays, but the 3 in the first 3 and 3 times 2 times 1 cancel, so you're left with 2 factorial. Plus 5 comes out front, you're left with x to the 4th. The 5 and the 5 cancel, leaving you with 4 factorial. That's cosine. Isn't that cool? And the negative 1 to the n is still hanging out there. You get x to the 2n minus 4 up front. It's kind of interesting right there, what's happening. All over 2n minus 4 factorial. And honestly, the nth term doesn't really matter very much. What matters is this pattern. So I'm going to erase the nth terms. I don't think they matter at all in the showing of this. I'm just going to put the plus dot 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 because I don't want to confuse anybody with those nth terms. So dot 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 dot. It just keeps on going on and on with that pattern. Now, that means that y double prime minus y is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus dot dot dot. Keeps going on like that. Minus, and we're going to subtract this. What's going to happen when we do y double prime minus and all of those things there? So you get negative 1 to the, so we get negative 1 plus x squared over 2 factorial. And I should say, I made an error here. This should be, sorry, y double prime plus y. It's my fault. That should be y double prime plus y is equal to 0. So negative 1 plus x squared over 2 factorial. And then we've got, so I'll put a plus there. Our other y value, which is minus x to the 4th all over 4 factorial plus dot dot dot. So, sorry guys, I didn't realize that error there in the beginning. That should be a plus, not a minus. So that'll be corrected in the notes for you. So all of that, when added together, wait a second, 1 plus negative 1 is 0. This term is the same as that term, but opposites, that's 0. This term is the same as this term, but opposites, it's equal to 0. It all ends up equaling to 0. So that's one way of showing it. The other way is saying, wait a second, this is cosine of x right there. And that's, sorry, the opposite of cosine of x. And this is equal to cosine of x. So therefore, minus cosine of x plus cosine of x is 0. So that's it. So therefore, y double prime plus y is equivalent to 0. Now, if you're ever asked to show that a differential equation is a solution to something and it's a power series, expand it out, put it into the equation that they gave you, right? So it'd be y double prime plus y in this case, and that ends up equaling out to 0. Very cool stuff. All right, I'll see you in the next one. Until then, peace.